Hello, everybody, to this Tuesday's edition of our COVID-19 induced API session training, which we for the last 14 times held already. And we discussed it internally, and given that the current situation with lockdown and the general impact of the pandemic on our lives, we have to accept that this becomes for the foreseeable future the new normal. So we actually also decided to change the format of these a little bit, and hold them from most likely starting next week onwards only once a week, but in a changed format, so that we have the first 30 minutes, one of these kind of input sessions from Michele or Simon or others, and then we'll bolt onto this a 30-minute session where the team here is available for question in an office hour style situation, where we also might be brave enough to ask you some questions so that the dialogue is going. So I will send out an email with the change of format and the information either later this week or early next week, and it will be from now on Thursdays. And we also make it openly available, not only word of mouth, but basically also promote this so that whoever wants to join can join. With that, I'm handing it over to, I think that was Simon today. No, not Simon, Michele today, because I forgot to put the names in the email. So I fooled myself to talk about building a journal profile using the Dimensions API, the part 2, identifying competing journals.
All right, thanks very much, Christian. I'm gonna share my screen and take over control here. Here we go, perfect. Right, so the topic for today is actually a continuation of what we have been looking at last week. So if you were there in last week's session, essentially we have taken one specific journal, and we've been looking at the authors and affiliations of that journal, of the people related to that journal, primarily from a perspective of a journal publisher, an editor, or an analyst that would focus on that journal specifically, and who wants to understand a bit better who are the people essentially publishing in that journal. And also trying to look at the question of who is likely to publish again soon. So we've been looking at pulling some metrics for these authors, like the number of citations, or metric scores, number of publications, and so on. The bit we haven't looked at, and that's the topic for today, is essentially taking a look at where else these authors are publishing. So gathering information about the other publications they have, then focusing on the journals these publications have been published in order to essentially come up with a kind of a journal competitors analysis. So essentially looking at what are the most frequent journals the same authors publish into as well. Now, I think the notebook today is actually a quite interesting use case, because it represents all of the three main reasons why people come to the API. So the first one is people come to it because they have some complicated query, or maybe they have an analysis that requires more than one query in sequence. So for example, citation analysis, or on, with reference to today's topic, you want to look at authors from a journal, and then for those authors, you want to look at their other publications, and then pivoting on the journal. So this requires several steps. So the API is great for this. It's not something you can do using the web application at all. Second, you want to automate this. You don't want to do it only once. If you are a journal publisher or a journal editor, you want to probably do it every 6 months, or maybe every 3 months, just to see what the things have been changing. And that's the second reason why people come to the API. They want to automate some kind of query composition. They want to build some reports that they can run over and over in order to compare results periodically. And finally, for this sort of report, since we're looking at many authors potentially and a huge number of publications potentially as well, the API is a perfect solution for it, because you can easily get more than 50,000 rows records you can extract using the web application. And so that's the third main reason why people come to the API. Oh, by the way, I should have put it into presentation mode. Here we go. Right. Most of you know already by now, I bet, that the API uses its own query language. This is called the dimension search language. It's a pretty powerful query language that was developed primarily for research analysts. So it's a powerful query language that doesn't require people to be developers or query language experts or API experts in order to be used. And that was one of the main reasons why we came up with our own language. For those of you who have been using SQL or SQL-like languages in the past, this language is quite similar to it. But it's, of course, also much simpler. And most of the operators and the functions you have in it are quite easily understandable if you speak the English language. And you can do a lot of it simply by copying and pasting queries, or people have done, and changing things a little bit. Now we have a wonderful documentation resource online, which is freely accessible, and it contains everything you need to know about the language. In particular, if you go under the query syntax section, it will tell you everything in terms of how to do full text queries. Essentially, if you're searching using keywords, or if you're using filtered search, if you try to filter or facet using specific properties of the objects we have in dimensions. But we also have some pretty interesting sections of the documentation that tell you more about the content types, about the objects available in dimension, in particular available using the APIs, and the different relationships between these objects. So dimensions, one of the main strengths of dimensions is the fact that we have so many different links across the different sources. So by using the API, it becomes pretty easy to jump from one object to the other. So for example, to look at citations from publications to patents, or the other way around, or from policy documents to publications, or from publications to publications, of course. And it's not just about citations. We also have many other links about researchers or about organizations. And so there's plenty here to dig into in order to build your data analysis projects using Dimensions API. The other interesting thing to keep in mind is that this website gives you essentially the A to Z documentation in terms of how to use the API. But if you want to look at specific, concrete, real-world applications of the API, we have a kind of companion website called the Dimensions API Lab that contains many cookbooks or recipes showing how different API queries can be sequenced and how data coming from the API can be then processed in order to answer real-world questions. For example, building a citation analysis for a group of publications, or profiling journals, the tutorial we'll be looking at today, or for example, studying patents, looking at how patents cite publications, and so on. So there's plenty of information on this website. All of these tutorials are fully open source. They're actually Jupyter notebooks that can be downloaded and run on your computer, or you can even run them online using Google Colab, which is a cloud-based Jupyter environment that allows to run Python code. Right, so back to my slides here. The other key thing to remember, as always, is there are different ways to access the API. The quickest one, the easiest one, is by using the web app. The web app, if you go to appdimensions.ai/DSL, or simply by going to the workflow menu and then API. So the web app gives you a kind of a query box where you can simply stick an API query in, and you can run it and you get the results right there. So this is a kind of a pre-built query that you will find every time you go to this page. And as you can see, the results come back in a format which is highly structured. There's lots of brackets, and it's a format which is quite popular with the developers and API consumers, and it's called JSON. It's fundamentally a list of different fields and object types separated by either curly or square brackets. Now, by going to this page and trying out a query, You can obviously see whether the query works, or you can get a feeling for the kind of data you can find using the API, which at the end of the day is exactly the same you would find using the web app. So the facets and filters you see in the web app are the same you can find via the API. But the point I want to make is that once you get to these results, there's probably not too much you can do, because very often your analysis would take several steps, or you have a lot of data you want to extract, or maybe you want to pull this data into another format, like a CSV file or Google Sheets. So really, this approach is primarily for trying things out and to see what's available in Dimension via the Dimensions APIs. If you want to make use of the data, there's two ways fundamentally you can interact with the API. You can either use a third-party software that has a data connector, something like Click, Tableau, or indeed Google Sheets, for which we developed ourselves an API connector, and that's the animation you see on the right-hand side there. So by using a third-party software, what you normally do is essentially throw a query at Dimensions, and then the software knows how to transform that JSON data into a table or into a visualization if you're using Tableau or something like that. So that would be another way to essentially becoming productive with the API and by using Dimensions data. Finally, the third way of doing things with the API is by using a programming language, something like Python or R. If you use a programming language, of course, there's no limit to the range of things you can do with the data, because essentially you can process the data any way you want. And so that's a solution that very often is chosen by people simply because it's extremely flexible. And also when people use programming languages, they use it in combination with technologies such as Jupyter, something I mentioned earlier, which is essentially a way of combining code and text together within a web document, or Google Colab, which is a free version of Jupyter that runs completely online. All right, so we've done the introduction, so I think it's time now to get started. So what I'm going to do, I'm going to the API lab. There we go. All right, so today we'll be looking at the fifth part of this journal profiling tutorial that looks at competing journal analysis. So what you see here is a kind of a rendering of the tutorial in HTML format. Of course, you cannot run this. So in order to run it, to do something interactively, I'm going to click on the Open in Colab button you see right there. And this essentially opens a fully interactive version of this tutorial that you can play with yourself, assuming you have an API login. And that's exactly the very first thing we'll be doing now. So I'm going to take a temporary username and password for this, and I'm going to log in here. Let's see if that works. So in Colab, and likewise in Jupyter Notebook, there's this notion of a cell. A cell is essentially a snippet of code that can be run. So every cell is a little bit like a little program in itself. It's kind of isolated from the other cells. It can reference the results of the other cells, but at the same time, it's kind of isolated. So you can run them at different times and not necessarily in sequence. So what I'm doing here, essentially, I filled in some variables with my username and password, and then I'm running the cell. There's other things happening in this cell which are worth noting. One is I'm installing Dinkli. Dinkli is a Python library we developed and maintained to simplify working with the API. So it makes it easier, for example, to log in. That's what I'm doing here. As you'll see later, it will make it easier to query as well, and to essentially transform JSON data into other formats. And then down here, I'm essentially loading up a few other open source libraries that are useful when you work with data in Python. And in particular, Pandas is a very popular library, which is a little bit like spreadsheets for Python. And finally, Plotly. Plotly is another free library that people can use in order to build interactive visualizations within notebooks. And finally, the other thing I'm doing right here is simply creating a folder name called journal profile data, where we're going to be storing the results of this analysis. Right, so I call the method dimcly login, and the method was successful. So it tells me here I'm now connected to the Dimensions API, specifically this endpoint. It tells me about the DSL version currently being run by that endpoint, and also tells me that I've been using a manual login method. And this is pretty much what you would normally do if you use a Google Colab environment. If you run things locally on your computer, there are ways to store your credentials on your computer. It's actually pretty easy. You just look up the documentation for Dimcly online. And of course, that becomes really handy if you have to log in out, often. You don't have to put in your credentials every time. So that's definitely something you want to look into if you use Python. Right. So I think now we're kind of geared up to start the analysis. So essentially, in a nutshell, what we want to do here is take the researchers list we previously extracted as in the context of the other tutorials for the journal profiling series. So we want to get all the authors for a journal, and then for each of these authors, we want to pull all of the other publications they have written in a specific time frame. Yeah, of course. And then once we have all of these publications, we kind of want to pivot on the journals, on the journal titles of the publications to understand how many publications per journal these authors have authored in that specific time frame. And that will give us a measure for what are the most frequent journals the authors of a specific journal publish in as well. Just a reminder, in the other series, in the other tutorials part of the series, we started out by looking at Nature Genetics. So the data I have available here is authors for Nature Genetics, I think for the past 5 or 10 years, something like that. So of course today we'll be focusing on Nature Genetics as well. But of course you can take these notebooks, modify the journal identifiers and make it fit your specific use case quite easily. So very first thing, we want to reload the data we obtained in previous steps. There's different ways to do this. One way here, you can just click on that link. It will allow you to download a zip file that contains the researchers data we previously loaded. So today I'm going to try and do things a little bit different, just because I've never done it before. I just tried it today, and it was quite cool. So if you use Colab, there's actually a really nice way of linking up your Google Drive, meaning that any file you have on your Google Drive can be accessed from Colab right away. So what I've done here, I just clicked on this Mount Drive button. This cell pops up, and all I have to do is just run that cell, and essentially a link gets generated that takes me to an authentication page where I simply have to say, yeah, that's me. I allow Google, my own Google Colab notebooks to access my drive, and then it gives me a secret key. So I'm going to copy that, close this window, move back here, copy the key, the authorization code in that box, and when that cell stops loading, that means my drive is actually available now. So if I refresh this page, hopefully you can see it. It's not too small. There's a new folder in my temporary Google Colab files panel, which represents my drive, right? So I can get rid of the cell now. So this bit here, where essentially I'm loading a CSV file from the previous tutorials, I can essentially go into my drive, and previously I loaded these files into my my Google Drive, and they're all here. Essentially, I downloaded the zip folder and I just put it in there. So if now I click on that file there, I right click and I say copy path. I'm gonna close this down now. And now I can replace all of that with something Colab understands, which is the location of that CSV file in Google Drive. So let's see if that works. Yeah, there you go. So now I've loaded my data set of 20,000, almost 20,000 researchers from Nature Genetics directly from my Google Drive. And this is something we have created in the previous sessions. And that's essentially a list of author names and identifiers, a count of how many publications they have, citations mean, all metric mean, last publication year, and finally the URL of this for the researcher profile of this person on Dimensions.ai. Yeah, in case you want to follow up on this person. And that's all we need in order to get started. So essentially what we'll be doing is take these researcher identifiers and look at all the other publications they have, and then segment it by journals. Simple as that. Now we have 20,000 researchers. That's it's not a big number, but of course it will take a few minutes to run through all of them. So for the sake of this tutorial, I'm just going to take the top 2,000 just to exemplify how the method works. But of course, you can take as many as you want. It's just a matter of essentially taking more time to run the notebook. So I have 2,000 researchers now, and the next step, essentially setting up the basic query we use in order to extract publications data we need for our analysis. And the query is actually not too complex. I simply have to say search publications with these authors, and the authors, I put them in a list. So I'm querying for more than one author at the same time. And then I can specify a time frame. Essentially, I want to do the analysis with publications from this year onwards. And of course, I want to pull out publications where there is a journal, some journal information. I'm not interested in books or anything like that for this. And also, I don't care about publications from Nature Genetics, because Nature Genetics is my starting point. And for each of these publications, I simply want to pull out the publication ID, the journal ID, and the journal title. That's all I need. Because eventually I'll be counting how many publications I have per ID and creating a journals dataset, a competing journals dataset. Now, there's a couple of things to point out here, which are useful to remember, because this is a common pattern that will pop up in many cases. Essentially here, I could have a separate query per researcher. I have my 2,000 researchers, and I can query all of their publications per researcher, but that essentially will result in 2,000 queries, which is a lot. And since you have to wait 2 seconds per query or so, it will take quite a bit of time, and it's not really necessary, because you can query for more than one researcher at a time. That's fine, and you can actually go up to 400 or 500 per query, and that's fine. And the only thing to keep in mind, though, is that of course the results coming back will be a merged set of publications for all of these publications, for all of these researchers. It won't be one research at a time. So once I get all of these publications back, I also have to eliminate duplicates. I need to make sure the list of publications is fully representative of the data I want to look at. So that's the one thing to keep in mind. And second, second is the fact that, of course, since I can put up to 400 or 500 researchers in this list, I need to break out my original list of researchers of 2,000 or 20,000 into different chunks. I cannot search for all of them via one single query. So if I have 2,000, I have to maybe make 5 or 6 groups of 400, and then have a query for each of these 400. Yeah, and this is really a basic pattern in terms of how to pull data from the API. So essentially, you have to break down long list of things into manageable chunks, and then query for each of these chunks, have a separate query, and then once you have all the data back, you want to merge it all together. And finally, the other thing to point out here is that, of course, if I query for 2 researchers, I get 152 publications, so not very many. Well, quite a few actually for 2 researchers, but for others, there could be many more. And especially if I have a list of 400 researchers in there, the resulting publications will be thousands, if not tens of thousands. And of course, that's an issue because every DSL query can return up to 1,000 1,000 records at most. You need to have a way to essentially go through all the publications available for a specific combination of researchers and journal and years and so on. And so what we'll see down here is that dmcli, the Python library we have, makes it easier to do that. You can simply say, for all of these results, keep querying until all the data are complete. And that's quite easy because you do it in one single command. Right, so let's see. Okay, so that's running. So what we do down here, essentially, we take the query we have been looking at and parameterize it a bit, yeah, so that it can be reused with other journals or with other years. So in my case, the journal ID is the one for Nature Genetics. I start from 2018, so 3 years worth of content, simply because it will be quicker to pull the data. And then I simply take from the CSV file I loaded, I take the researcher ID column, so the full list of researcher IDs, and turn it into a list. Yeah, because that's the list that I will use to fill in the dynamic list of researchers fields I have in my query, right? And that's essentially what's happening. All of these curly brackets are kind of placeholders for these variables I've set out up here. So for the journal ID, the start year, and the list of researchers. And so what's happening down here is this kind of chunking, essentially slicing activity, slicing process of researchers I was talking about a moment ago. Because essentially here I say, take only 400 items at a time from the researchers list. And then for each of these groups, create this query, fill in the query with the researcher IDs, and run the query. And then at each iteration, the results are all added to the same kind of, exit list, same variable called pubs. And so I keep adding until I go through all the researchers in my original list. The other thing I mentioned earlier, the fact that for every single query, you may have more than 1,000 publications, that is addressed by using this query iterative operator, which is something dmcli provides, which is essentially a shorthand for something that API allows you to do, which is paginating through different pages of a result set. So if my query returns more than 1,000 results, you can say, give me page 1, give me page 2, give me page 3, and so on, until you run out of data. By simply saying dsl.query iterative, you can essentially do all of that in the background. You don't have to worry about it, and the data are stored within a single variable. And that's essentially what's happening here. If you try this out at home, I was going to say, if you try this out by yourself, you may want to turn that verbose variable to true, because essentially that allows you to see what's happening in the background. Yeah. And that's probably interesting to know if you're learning. So in this case, every time there's a query, every time, essentially for every chunk, I'm querying for all the publications related to that group of researchers. And as you can see, I'm querying 1,000 at a time. So this is the first chunk of 400 researchers. There's 30,000 publications in total. And then it will go through the second chunk and third chunk and fourth chunk and so on until it gets to the end of it. Okay, we can let it run again. And once it's finished, the final thing to keep in mind, and we can go back to to our query up here, is that, of course, since I'm querying for researchers in different steps, if you think of two co-authors, if they do happen to be in different groups, you would get the same publication twice, right? Because the same co-author would appear in the first group and the second co-author would appear in the second group, right? So the same publication ID will be added to the final result set twice. And we don't want that. That single publication should count as a single one. So once you do the sort of very, very common pattern of, separating list of things into chunks, querying, and then putting data together again, you always have to think about whether you want to remove duplicates from your final results. Yeah, that's That's another very common pattern, and you know, it's pretty easy to do that, especially in Python or even in R. This kind of data manipulation libraries, they make it super easy to do. In this case, all you have to do is take this pubs variable and simply say draw pool duplicates based on this column, and the column is the ID column. Essentially, all rows, all records with the same publication ID should be removed. All right, so what that, since that is finishing, what I'm gonna just mention is that we have a very nice tutorial Simon presented a few weeks ago about working with lists in the Dimensions API. So if you're interested in this kind of pattern, the one I was talking about, essentially taking a list of things and using them to query by chunking them out and then bringing data together, this tutorial gives you really all the possible ways to do it, and also shows you how to apply it in different contexts. So very, very interesting tutorial to look at as a follow-up activity. So in the meantime, this is finished. So it's gone through all the researchers we had. So let me run this cell again. So here I'm removing the duplicates. There we go. As you can see, I have a nice data set where I have one record per publication. I've got the publication year as well, the journal identifier, and the journal title. So the final step before we can actually start working with the data is that we want to go from a data set like this to a data set where every journal ID has its own unique row. Essentially, here things are grouped by publications. I want things to be grouped by journal. That's also pretty straightforward by using pandas, you know, this data manipulation library. What I'm doing essentially, first of all, calculating a total of how many publications exist per journal. I do a kind of group by operation on the journal ID column. Then I also do a group by on the journal ID and year column linked together, because I want to do some analysis by year. Essentially, I want to have a yearly breakdown of the journal competitors. So once that is done, I have my journals data set. I want to remove duplicates once again, in case there's any duplicates popping up. I sort the data by the total number of publications, and I save it. And that's what we get at the end. So we got the year column, journal ID and title, and the total number of publications the grand total and the total by year. And that essentially gives us the what we want. And now we can build some really, really simple visualization just to have a quick look at the data to see whether things make sense. And for this, I use Plotly. As I mentioned, it's a really nice open source library you can play with. The nice thing about it is that the charts are extremely interactive. You can zoom into them. You can double click on the legends to hide and reveal certain features. So what I'm doing in this case, for example, I'm taking these journals list I just built. I take the top 100, just to not to make the graph too busy, and I'm building a bar chart simply by saying put the title field on the X dimension and the total year on the Y dimension, and also I want to segment things by year. So essentially here what I see are the top journals competitors, and the years are actually represented using colors. So for Nature Genetics, I see bioRxiv, well, quite unexpected. Well, we actually quite expected that as the top competitors, and then the European Neuropsychopharmacology journal, then other Spring and Nature titles, and so on. Now, another nice way to look at this very quickly is to essentially, instead of plotting the yearly distribution using colors, to essentially have a different chart for every year, just to see, just to look at the yearly distribution of each of these competitors to see whether there's any pattern, you know, if any journals are actually incrementing or decreasing the amount of publications they have. And actually there is an interesting pattern coming up in this case, and quite, surprised me as well. I wasn't too sure what to make of it, but essentially, the European Europe Psychopharmacology Journal has a massive bump in 2019. So normally, actually, there aren't many publications there. So that led me to dig a bit more into it and understand what was going on. And essentially, what turns out, and I was looking at the homepage of the journal, on that year, they started publishing a lot of conference proceedings, and the metadata they sent to Crossdrive and to us as well, it doesn't say that these are conference proceedings. These are just articles, and in many cases, these proceedings are just abstracts. So of course, the number of publications they do per year, is 5-10 times as big, and that of course changes the overall statistics. But that's essentially how you would go about building a competitor journals analysis. So going from the authors to the publications, and then pivoting on journals. And that's all I had for today. So let me see if there are any questions or comments. No. Always end up losing my. I do not see any.
No.
Okay. Okay.
No questions. This time was all clear.
Okay. Good then.
Thanks a lot. And as I said, on Thursday, it will be still the normal session, and Simon will then present his work on doing a COVID-19 analysis of an upcoming report. And then next week we will be to a different frequency, open to everybody, and we will promote it also a little bit on the website. Then one session per week going forward. Thanks a lot.
Lovely. Thank you.